Hey everyone, so in this video we are going to talk about how your calculator can actually help you out a lot when you are able to use it. Now we know that a big chunk of the AP exam you're not allowed to use your calculator, but for the chunk where you are able to use it, I want to make sure that you're able to use it wisely. So we are going to first talk about how we can take a derivative on our calculator. So when we are looking for a specific value of the derivative, so for example, right here we're looking for f prime of 2. Our calculator can actually do this for us. If we were going to do it by hand, we would take the derivative and then we would substitute x equals 2 and we would find it. Now, you can do that, that's fine, but your calculator can actually do it for you. So, if you guys have your calculator with you, which you should, grab it for me. And we're going to hit the math button, so right below the alpha. And I'm going to scroll down to show you, but normally you can just hit the number. But it is option 8, where it says n derive, and then it's got a parenthesis. All right, so we're going to actually hit that. And it's kind of nice because it pops up with this option for us. So before we even do anything, I want to write that down. The buttons we need to hit are math, and then we're going to hit option 8, which is n derive. All right, and when you hit that, this is what it pops up with. It gives us d something of some stuff, and then we're evaluating it like this. So when we look at our example, we're going to be plugging in this function here, and we're taking the derivative with respect to x. So we are actually going to plug in our calculators then d dx of 3e to the 2 sine x plus 7. And we're going to tell it to evaluate it at x equals 2, because that is the function value that we want. So d dx, so that's where the X button is, by the way, down here, right here, in case you guys don't know that already. And we're going to do 3e to the power of 2 sine x, end those parentheses, and get out of our exponent, and then do plus 7. And we're going to go out of the parentheses here, and it wants us to tell it which x value we need to evaluate this at. This is at x equals 2. All right. By the way, make sure you're in radian mode, okay? Just in case you didn't check that already, make sure you're in radian mode and hit enter. So what we can say then is that f prime of 2 is approximately negative 15 point, by the way, we're going to round to 3 decimal places, so 389. All right, now something that's really important to pay attention to is that this only works for specific values of x. So we knew that we wanted the derivative at x equals 2. This doesn't work to take the general derivative. Like, we can't plug this in and it'll take the derivative of this with respect to x. We can't find f prime of x on the calculator. We can find f prime of some value. All right, so make sure that you're very careful with that idea. Now we can also use our calculator to graph a function so that we can analyze the derivative. Now there's not really much to write in terms of buttons here other than y equals, because we're going to actually graph this function. But let's look at the example we're going to do. So we're given f prime of x is this function, and we're asked where f is increasing on the intervals from 0 to 10. Well, we know that f is increasing means that we're looking at where f prime of x is greater than 0. So we're going to graph this function and we're going to see where it's greater than 0, because that's actually what we were given, was the derivative. So we're going to go to our calculators and we're going to graph. So y equals, and we're going to plug in our function, which is e to the 1/2 x, and then minus 8. Make sure that minus 8 is not part of your exponent. All right, and we are going to graph this. And that's what our function looks like. Now, I really only care about the interval from 0 to 10, so mine right now is on the standard window, which is fine, but if we wanted to, we could change the window. So we can always go to our window and change it from 0 to 10, since that's what we're looking at, so we can get a better idea. But we know that we're looking for where the derivative is greater than 0. Well, since we graphed the derivative, we're really looking for where it's above the x-axis. So that's starting here, and then it just keeps going. So we need to find that value. So you guys have probably done this before, but we're going to hit second, trace, because that's going to bring up our menu for calculate. And we want to calculate a 0, because we want the x-intercept. So it's option number 2, and hit enter. Now when we look, it asks for the left bound, so we need to go to the left of the 0, which in this case means we're going to want y values that are negative. We want to be under the x-axis, and we need to hit enter. Then it asks for the right bound, so scroll to the right, or in other words, get a positive y value now, and hit enter. And when it asks us to guess, we just hit enter again. And it gives us the x-intercept. All right, so we can see that this crosses the x-axis at 4.158, oh, 9, excuse me, got to bump it up one, which means we can say that f of x is increasing on the interval from 4.159 to 10 because f prime of x is greater than 0 on this interval. So it's kind of nice because we didn't have to worry about messing with this, with graphing this on our own and then figuring out where it crossed the x-axis on our own. The calculator did it for us. So y equals, and then to get to that calculation, we had to do second, and we had to hit trace, which brings up the calculate options menu, and we want option number 2, which is to find a 0. So just in case you need those buttons written down for later, although you guys should have done this already. Alright, so let's look at what some actual examples would look like on the AP exam. So the first derivative of the function is given by f prime of x, so we're given the first derivative, and it's sine of x squared. So which of the following values does x have a local minimum? So let's think about what it means when f has a local minimum. Having a local minimum means that f prime has to change from negative to positive. In other words, it means that we went from below the x-axis to above the x-axis if we were looking at the graph of f prime. Okay, and since that's what we were given, that's what we're going to be analyzing. So, and by the way, we went from negative, which means we were decreasing, to positive. So that's how we know that that's a local minimum, because we were going down and then suddenly we were going up. So when we're looking at the graph of f prime, we're going from below the x-axis to above the x-axis. So let's go ahead and actually graph this function. So sine of x squared, sine of x squared, and we're going to graph that. Whoa. Okay, so let's change our window up a little bit because that's a little intense. We're going, let's see, look at these options here. These options are really only between 0 and 3, and this is oscillating back and forth a lot, so I'm going to change these windows for sure. So I'm going to go from 0 to 3 for my x values, and I'm going to go from -1 to +1 for my y values, so I can get a better idea of kind of what's going on in this graph. Okay, that's so much better, right? Do you guys agree? I think so. So we're looking from where the f prime is changing from below the x-axis to above the x-axis, which means I'm going from a negative to a positive. So that must be right here. So I'm going to use that same option I just did and find the 0 of that function. So second, trace, and I want option 2. And I need to be on the left side of that 0, so we need to scroll over. And we're going to hit enter. And then we want the right bound, so go above it and hit enter. And we have a 0 at 2.507, which is actually option A. So we're good. All right, one more quick example. All right, so now we are given the graph of f is this function. Now we're given the original function. So it's always very important to pay attention to what we were given, by the way. So we're given this original function, and we're looking for where it changes concavity. So concavity we know deals with the second derivative. So this question is really asking, where does y prime change sign? Y double prime, excuse me. So we know that that really means we're looking for where the slope of y prime changes. So in other words, where y prime changes from increasing to decreasing or vice versa. So where does the derivative change increasing to decreasing? Because that's going to give us our points of inflection, which tells us that we've changed concavity. Now we're given the original function. If we wanted to, we could take the derivative, and we can take that derivative by hand. We've got some some power rule, and then we've got a trig function, but that's fine. We can take that by hand if we really want to. But one really cool thing about your calculator is that it will graph a derivative for you. So I told you that it'll take a derivative at a specific point, and it won't take the derivative of a function, but it will graph it. So what we're going to do is that same function where we were able to derive, we're going to use that to graph. So we're going to close out of there, and clear that out, excuse me, and we're going to go to y equals, and we're going to go to math and choose option 8. All right, now we're going to take the derivative with respect to x, so that part doesn't change. And we're going to plug in our function, which is x to the third plus 6x squared plus 7x minus 2 cosine x. Okay, now the different part here is that we're not going to be taking the derivative with respect to a specific value. We're actually going to put x in there. So I told you you couldn't do this when we were trying to get a number for the derivative, and you can't, but because we're trying to graph the derivative for all x's, we're going to take the derivative with respect to x and say evaluate it for all x's here. So let's write that down really quick. So what we're doing is we're going to y equals, and we're plugging in d dx of x cubed plus 6x squared plus 7x minus 2 cosine x, and we're telling it to do it when x equals x. Okay, and doing this, we will get our calculator to graph y prime, because then we can analyze y prime to figure out where the concavity changes. So let's go ahead and tell it to do that. Now, your calculator is figuring out the derivative and then it's graphing it. So it takes a while sometimes. So kind of give it a second to think, right? We all need a little bit of time to think. The calculator does too. But, oh, you know what? I just realized that our window is probably funny. So I'm actually going to go to Zoom 6. I'm going to go to my standard window so that hopefully I can see something. And again, you can kind of see it working in the corner here. But there we go. Here comes our graph. So that is the graph of y prime. So what we're looking for is where y prime changes from increasing to decreasing or decreasing to increasing. So in other words, we're looking at this minimum value right here because f prime was coming down, coming down, coming down. It hit a low point and then it decided to start increasing. So we're going to find that minimum right there. So you guys have probably done this also, but second, trace. and we're going to calculate the minimum, which is option number 3. We need to go to the left side of it. So I'm going to go right here. Then we're going to scroll to the right side for our right bound and tell it to guess. So we always just hit enter when it asks us to guess. And we have a minimum value at x equals negative 1.894. And it gives us the y value also, but I don't necessarily care about that. It's only asking for the x value, so that is option D. Alright, so in class you guys will get some practice with your calculator, and then we're really just going to continue tying everything together and get you guys ready for your test. Alright, I'll see you guys in class. Bye!